So now we're going to talk about a situation that does occur often in mathematics, the sums of powers. Now, I would sit and do all the proofs for you guys, but the proofs would take so long, we'd probably sit here for like another 20 years. Well, it doesn't take, I'm obviously exaggerating, but the point is I don't want to spend so much time proving these, because these are all the proofs that you guys need to do for these are in your exercises. So we'll state the sums of powers here. And this is kind of a shortcut, and this is a lot faster than having to do this by hand, because this is what your calculator does. So we have a few different ones your textbook gives you. So the sum of all numbers is simply n times n plus 1 divided by 2. And then you have b, the sum of squares, which is 1 plus 2 plus 9, 16 plus dot 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 dot, n squared. Is going to equal n plus 1 times 2n plus 1 all over 6. And then you have the n cubed formula, which is 1 plus 8 plus 27 plus 64 plus is equal to n squared times n plus 1 squared divided by 4. That one's really tricky, because you might be tempted to switch the two squares formulas. Please do not do that. Okay. And then we have n to the 4th, 1 plus 16 plus 81 plus. And now the formulas start to get ugly. So it's n oh, this one's missing an n, by the way. And this ends up being n times n plus 1 times 2n plus 1. This kind of it starts to develop a pattern, actually. All over 30. There's actually a way to do it for n to the r. But it's a pain in the butt to do, and we'll not do that. It's beyond the scope of this class. So, and then we have, lastly, letter E in the situation. We have 1 plus 32 plus 243 plus all the way n to the 5th power equals n times n plus 1 times 2n n squared times n plus 1 squared times 2n squared plus 2n plus 1 all over 12. A lot of formulas to memorize. The only one I would actually stick to memorize are the first and the second one. The third one you don't necessarily need to memorize so much. So let's do an example of how to work with these formulas. So, let's see. So let's find the sum of the 12 numbers of 3k squared, and then minus the sum of the 10 numbers of 4k using the formulas. Alright. So you could sit and calculate this all by hand by plugging in 1 squared plus 2 squared plus 6 squared plus 4 squared plus 5 squared plus 6 squared, but that takes way too much time. So let's not do that and say we did. Alright. So in each situation, first thing I want to do is factor out the coefficients. Alright, so it becomes 3 times the sum of k equals 1 to 12 of k squared minus 4 the sum of k equals 1 to 10 of k. After we factor out the coefficients, wow, that looks horrible. Okay, hold on, let me fix that end of the puzzle for you. And then we'll use the formulas here in each situation. Right, so it becomes 3 times the formula. In this case, the formula for squared is, of course, n times 2n plus 1 divided by 6. The minus 4. The sum, the formula for this one, is, of course, n times n plus 1 divided by 2. N in this situation is 12, and n in this situation is 10. So that kills that twice. That kills that twice. This ends up being 10 times 11 times 2. So of course 10 times 11 is what? 110. So 110 times 2 is of course 120. So we'll subtract 220 from whatever the heck. And then from here we have 12. And so then we end up with 12. 12 into 24 plus 1 is 25. And you end up with 12 divided by 2 is 6. So you end up with 6 times 25, which is simply 75, times 2, which is 150. Okay. So 25 times 6 is 150. Now, 150 minus 220 is, of course, negative 70 as the sum of these numbers. So instead of doing all that work, we cut our work down to size, so it's not too difficult. Okay. Factor out, then we use the formulas. Simple enough. I'll have you do one on your own, and then we'll get to some other stuff. There we go. There you go. Have fun with this one, and we'll get back to you on that in a few minutes.